Hi, it's Kevin Lebates here, and today I would like to start a series on wallets in blockchain. And in order to do that, I need to start at the very beginning, namely with randomness. And this ties in neatly with a nice chat I had with Charles from Resonant Security and a couple of people from Quantum Computing Inc., a technology company looking at hardware and software relying on quantum mechanics to solve problems in the computer space. And the reason why quantum mechanics is important in randomness will become apparent as I talk a bit more about randomness. So back in the 1600s, when Newtonian mechanics and calculus and things like that were developed to a fairly advanced stage, we ended up as human beings with the feeling, in the scientific world anyway, that the universe was fundamentally deterministic, that we lived in a clockwork universe, and provided you knew the right equations to model that universe and you put in the right initial parameters, you could predict with certainty what was going to happen. So you can think here, for example, about tossing a coin. You don't know as an individual whether it's going to come up heads or tails, but if you had good cameras to be able to capture exactly how much force and spin was imparted on the coin, you'd be able to predict whether it would land heads or tails using simple Newtonian mechanic equations. And the deterministic model of the universe was developed and refined further, and we see things such as relativity coming in to explain what happens when you're moving really, really fast, or when things are happening on a big and grand scale. That's based on the work of Albert Einstein. Now, at the same time as relativity was being investigated and developed, another branch of physics was emerging, quantum mechanics, which is concerned with the very, very small. And it turns out that when you go down to the microscopic, let's say nanoscopic level, or even smaller, of the universe, you move away from a deterministic model and you end up in the world of probability. You can no longer talk about things being in particular places and moving at specific velocities. Everything becomes a probability wave. Things have a high probability of being in one place and a low probability of being in another place, but you can't be sure where they are until you measure. And through the process of measuring, the measurements for the other parameters it becomes impossible to perform them. This is things like the Heisenberg uncertainty principle, where you can know how fast a particle is moving, but then you don't know where it is, or you can know where the particle is with more and more accuracy, but then your measurements of speed become less and less accurate. And the neat thing about quantum mechanics is that it provides us with true randomness. So now I finally got to the randomness part. If you look at randomness in mathematics, it gets a bit confusing because there actually are deterministic forms of randomness. When you have a pseudo-random number generator, that's a function in mathematics that is deterministic, which means if you start it with the same parameters, you'll get the same sequence of numbers again and again and again. So you and I running the same equation with the same seed value or starting value will get the same sequence of numbers. So in that sense, it's not random, it's deterministic. However, given a seed, without cranking the handle on the random number generator, you can't predict what the 4th, 5th, 6th, 7th, 1 millionth number in the sequence will be, other than by just doing it. So in that sense, it's kind of random, in the same way that I don't know, if I'm tossing coins, what the 100th coin toss will be. Will it be heads or tails? The only way I can find out is by tossing a coin 99 times and then paying careful attention when I throw it the 100th time. So this also ties into something known as chaos theory. And chaos theory is a branch of mathematics where you have mathematical models that are deterministic, but a tiny change in the parameters that you use for the model causes a huge change in the output, making these chaotic systems very unpredictable, even though they are deterministic. So that ties back to this pseudo-random number generator equation that I was talking about. Now, in blockchain, wallets are very important. They are the software that individual users use to interact with the blockchain and probably most importantly, to manage their private keys, because the private keys are what give you the control over the assets that are assigned to you by the ledger. And as a result, you want to make absolutely sure that your private keys are truly and totally random. And human beings are really bad at picking random numbers. That's why you need a random number generator to generate your private keys, because if a human being sits down and starts going, well, I'm going to pick 256 random heads or tails or zeros and ones for my private key, the odds are that they're not going to pick a random one, and the hacker will be able to reduce the search space that they need to brute force to try and find that private key, and therefore your public key, find your assets and take them off you. So having a good random number generator is very important. And this is where quantum mechanics kicks in, because there are quantum mechanical processes that can be used to generate truly random numbers. And so, for example, the company I mentioned, Quantum Computing Inc., one of the things that they provide is mechanisms and devices for generating truly random numbers. And they work on surprisingly simple principles. For example, something as simple as an LED, a light-emitting diode, tuned to output very few photons, and a light detector at the other side of it to count those photons, gives you a quantum process that allows you to generate truly random numbers. You just fire it up, it's emitting very few photons. You know approximately how many photons it's going to emit over a period of time, but you don't know when they're going to be emitted. There could be none for a while, and then there could be a burst of them, or there could be, it's a random process. So something like that can be put in something as simple as a USB stick and used as a true random number generator. There are also other good mechanisms for generating random numbers that don't rely on quantum mechanics. For example, thermal noise in a resistor can be used, but we're finding more and more that quantum processes are the best way to obtain this true randomness. And as somebody who has looked at mathematics and the philosophy of mathematics, I have to admit I still have a kind of an unsatisfied feeling about this randomness of the universe. I have this gut feeling that it should be a clockwork universe, it should be deterministic, because how can the universe decide when a particular process is going to take place? When is a radioactive isotope going to decay, or an atom within it? When is a photon going to be emitted? How does it decide? But of course, ultimately, from what we can tell, at that level, there's no consciousness going on here. It just sort of happens, and it is the way it is. Now, Einstein was unhappy about this too. In fact, he once said, God does not play dice with the universe, which was him expressing his dissatisfaction that at the microscopic level of the universe, there does appear to be true randomness going on. Now, Niels Bohr, the quantum mechanics physicist, responded, Einstein, you've got to stop telling God what to do, which is a neat way of encapsulating that the universe just is what it is. We observe it, and there's plenty of evidence, scientific evidence, that at the quantum level, things are truly random and unpredictable as individual events. Of course, as an aggregate of the whole, probability kicks in and we can have expectations. That's how we can know that although you can't predict that a particular atom in an isotope is going to decay at this moment, what you can do is say, well, if I've got a kilogram of this isotope, I know how much of it will have decayed over a given period of time, and that is predicted to a very, very accurate level. So that's randomness. In the next videos, I'm going to talk about how that randomness is used to generate your keys, and I will be talking about hierarchical deterministic wallets in particular. But I hope you found this one interesting, and I'll see you all in the next video soon. Bye for now.